All right. Hello, welcome back. All right, so the new assignment went out today, and it's due in 2 weeks. That'll be this Monday in 2 weeks. And I'm sorry, it's in the middle of Thanksgiving. So basically, it's just a continuation of what we've been building. You've already created, let's see, the Angular front end, right? You've already created client-side web services that send out HTTP requests to a server. You've already done that. Server-side web services, right, that answer, that responds to these HTTP requests, right, the ones that are listening for incoming HTTP requests, right, the gets, the puts, the posts, right, the deletes. You've already created a data model for the forms and users but they update server-side arrays, right, that contain instances of each one of these objects. And so what this assignment is asking you to do is to go on the next step, and instead of use and we've been doing this for the last couple of weeks, using Mongoose and MongoDB to store, retrieve, update, delete data from a MongoDB instance. So this assignment is asking you to do basically apply what we've been doing for the last couple of weeks, and your assignment, right, extend it so that it persists the data in a MongoDB database, right? So let's see. This kind of tells you what you've been, where you have been, where we are, and basically it says, well, reuse what's right. So use the client and server containers that you already have from the previous assignment. Just extend the model so that instead of using the arrays, right, the in-memory arrays, to use a MongoDB instance. The general requirements are, from the previous assignment. They still are still there, right? So the same left-hand side, right-hand side, the same header, the same footer, right? The same links, the same views of using ngView for navigating through a single-page application. Those still apply. Same implementation for web services, the URLs that you're using to communicate, right? The controllers, the client web services, those still apply, right? That's still true here. The same requirements for the server side web services and the data models that you've implemented in the previous. The same CRUD operations, that still applies. But it asks you to go on and install a MongoDB instance, which you should have already done this. Install a MongoDB instance. You configure database/data directory, and then install the Mongoose, the module, right? The Mongoose module locally using npm install for Mongoose, and then it asks you to modify or refactor that you already have, right? So you already have, user.model.js and form.model.js. You already have that, right? But currently, it's manipulating an array, right? An array of objects. So what this asks you to do is that instead, right, enhance it so that you're going to implement a schema, right? A user schema, like we did last couple weeks, right? You implement a schema that holds all the properties of a user, such as properties that represent the user. Also that to use the appropriate data types, and to store your data, right, in a collection called CS5610.assignment.user. Okay, I gave it this name so that I'm not clashing with any collection that you might already have in your database. You might have a CS5610.project.user, right? Maybe you already have a user collection that you're using for your project, right? That you're playing around with. I don't want to clash with that collection. So this collection name, right? That's the name of the collection. For the user schema. Then in the user model that you already have, right? Require this schema, so load it into your model, right? Like we did we've done in the lectures. So require it, and then create a model out of that schema that you load and you require. Okay, right? And then instead of using the array, right, to search for things in the array, instead use the Mongoose API, right, to find users with a particular ID or find a user for a particular username and password, right? So use the finder methods that are in the Mongoose API to retrieve the data from the MongoDB instance. Also, because as we've shown in the last couple of weeks, whenever you're talking to an asynchronous process, right, you need to deal with this asynchronicity, and so we're saying to use promises for the Node.js implementation of the model to talk to the database, right? Remember that we've been using promises on the client for a while, right? But now, because we're going to be talking to a database, which is also a synchronous process, to please use promises, right, to talk to the database, right? We've done plenty of examples of that in the last couple of lectures. If you feel that you need, additional API methods, feel free to implement them. Okay, but at least you'll need those. From the previous couple of assignments, you'll need a find by ID also, right? Which is not listed here, but you should implement that as well. The mock data. So for the previous assignment, you were using a mock data, right, for a list of users. I think it was like 5 users, right? Alice. So what I'm suggesting here is that to use the mock data, right, to pre-populate, right, the database, right? So you can import that JSON array, right? You can import it into MongoDB so that you have, a list of usernames. For the form, so in the form, in the previous assignment, you had already implemented form model, right? Form.model.js, right? And I believe I had also given you mock data for the form, right? And, properties such as labels and the data types, right? So what this is asking you to do is to implement it using a MongoDB schema, right? So for the form model, first it asks you to do the field schema, right? Each field has its own schema, right? A field has a label, the type of that field, right? A field has a label, a field type, a placeholder, has options, right? If it's a checkbox, you have options, right, that you can click. So depending on the field type, either options is useful or not, right? If you're text or text area, then you don't really need the options, right? Because text and text areas are rendered as either a single line or multi-line text, right? If instead it's a radio checkbox or select, ooh, I forgot something, right? If your radio checkbox or select, then the options mean something to you, right? Right. If it's a radio, then the options, right, a list of radio buttons, right? If you are a checkbox, then the options is used for rendering a list of checkboxes, right? If it's a select, then the options is used to render, right, a drop down with all those options. Yes, right? Right, where you have an input or a text area, and then you can set the property for a placeholder attribute, right? What else? That's about it. So yeah, so it asks you to create a field.schema. There it is, right? Right, for this, you're going to use mongoose, right? So you're going to do mongoose.schema, right? And you create a JSON object that has the schema in there, right? Then it asks you to refactor the model for the form, right? As an array of forms, right? And then when you create a new form, you pushed an object to the array of forms, right? What this one is saying is, well, create a schema for the form, and a form has, for instance, a title, who created the form, right? Who created the form, a user ID, and the fields. The fields themselves is an array, right? An array of fields. One form has many fields, yes? Right? We kind of did this in the previous assignment, in the previous lecture, right, on Thursday, where you have an embedded schema, right? So the field property is an array of field schema. So this is an embedded schema, right? You have a form that has an array of fields, right? It's an embedded schema like we did on Thursday. Title and user ID, those can be just plain old strings. The collection, right, to use for the form here is CS5610 assignment.form. Notice that there is no collection for fields, see, right? Because it's an embedded schema, right? But notice that the form, notice that this is kind of a, you could argue this, right? Because you could say, well, a form has a one-to-many relationship with fields, right? One form has many fields, yes? A user has a one-to-many relationship with forms, right? Right? A user has many forms. Right? A user can author or create many forms, right? But notice that the architecture and the design we've chosen here is that even though we have a one-to-many relationship between users and forms, forms has its own collection. See that? It's not embedded inside of the user schema, right? And the reason we did that is that unlike forms and fields, if I destroy a form, there's no sense to keep around the fields, right? There's a lifecycle dependency. If I destroy a form record, I don't want to keep any field records around, right? So we decided to embed it, right? It's embedded schema. We decided to embed the field schema inside of the form schema. But a user, if a user is removed, right? Again, that's a business decision, right? Do I want to keep around forms that were authored by users, right? If my answer is yes, I want to keep those forms, right? I want to be able to look at those forms regardless of who created them, right? Even if the user is no longer in the system, I want to keep the forms, right? Right? In that case, I'm deciding to have the forms live in a separate collection. You see that? Not embedded in the user schema. Because if I embed it, that means that if I remove the user, the forms are gone, the fields are gone, everything's gone, right? So this is kind of, I want things to be, we talk a little more about this in our database course, where we say, is this an aggregation? Is it a composition, right? What's the life cycle dependency between these records? We decided this to be an aggregation, right? Where the forms exist, the form's existence is independent. Obviously, notice that we have, to maintain the relationship between these collections, notice that we have this user ID, have this user ID, which is, this should come as familiar to those who took relational databases. This is kind of like a foreign key, right? It's saying this record, right? This record of a form. Hey, I belong to that user over there. So you can have lots and lots of forms, but with the same user ID, saying that user created us, right? Right, that's a very common implementation in relational data. Children referring to their parents, yes, right? That's very, very common. In object orientation, it's kind of foreign, right? It's kind of this inverts the relationship, because from an object's point of view, in the object model, typically it is the parents who know about their children. Form has many children, which are the fields, right? A form has many children, which are the fields, right? It is the form who knows about the children's fields, yes? The fields don't know anything about the parent form. You see that? Right? That we're more used to that kind of data modeling, right? Where the parent knows about the children. Here, it's inverted, right? The child knows about their parent. In relational databases, we can only do this modeling, right? Where the child knows about the parent, right? You have foreign keys, right? This is a foreign key that is relating to a parent user ID. But in MongoDB, in a non-SQL database, you have the option to go the other way around, right? You have three options. This one, the foreign key, right? Where the form points to the parent user, right? Which is this one. We have the other one, which is the embedded model, where you have a form having an array of fields. That's the other option. We have a third option. Instead of having this user ID here, we could have, right, in the user model, we say that we have, first name, last name, username, password. We could have said forms. Okay? Key, right? Where the parent has lots of foreign keys to their children, right? We don't have that option in a relational data model, right? Right. Typically, it's always the child who has a foreign key back to the parent, right? Here we have the additional option of the parent having an array, right, of many foreign keys to its children, right? So we have three options: the embedded schema, we have the foreign key back from a child to a parent, and we have an array of foreign keys to their children, right? We're not going to do that, but it's there if you want to, right? You could go both ways. So anyway, so in this one, it's just using a foreign key. Those of you who've taken 5200 and or have done relational databases, this should be very familiar to you, right? Of having these foreign keys relating to their parents. Field property. Okay. What else? All right. Then you have the field property, right? Saying that it's going to be an array, right? An array of embedded schema, field schema. It's asking you to use proper data types, the collection. It's asking you to refactor form.model, right? To use this new, right? To use the Mongoose API to interact with the database, you'll need to use promises now, right? I believe in the previous one we didn't use promises because it was just an array, right? It's you were manipulating an array in memory, right? So there was no asynchronicity, right? But here, because we're going out to a network connection, right, to another data, to some other process, it needs to use an asynchronous mechanism. In this case, we'll use promises. Okay? Web services, you should not have to modify the web service, right? Hopefully, I don't believe you need to modify the web service, but if you do, make any changes you think you need to make, right? Client side, I don't modify anything on the client side, right? Most of this will be server side effort. But again, if you think you need to change a couple things here and there, modify them. Right, that makes sense. Any questions? I believe we've covered all the topics that we need to be able to accomplish this this assignment. Also going out today will be your project assignment for database. I mean, not to a server support for your particular project, right? For that, I've created a kind of a requirements document for the final project. These are somewhat broad requirements. Most of these we've already talked about this in class, right? But I just want to formalize this, right? And it's listed here. Where's my mouse? Okay. So page requirements. So mean stack. I know some of you have come to me if you could use other technologies, and really, like, the whole point of this is to learn how to create single-page applications, right? And to use this particular technology stack. It's it's very popular right now out there in the industry. Lots and lots of jobs out there looking specifically for this type of technology stack. So yeah, so any effort, please stay within this stack, technology stack. Excuse me. So page requirements. So at least there should be 4 distinct pages. I know many of you have much more than 4, and that's great. But these are the 4 top pages that I'm asking you to do. A lot of are very informational, or what I call brochure pages. They're very static pages, right? Just to give information about who we are and whatnot. I'm not considering those, right, as required pages, but these would be required. So one of them is the landing page, the home page, right? Look phenomenal, right? You have to come to this home page. It says wow, right? It should look very polished, very finished. Okay, you should come to this page, and it should be very inviting, right? To your first page, right? It should look very professional. It doesn't have to be complex, right? I mean, look at Google, right? You just have one search bar and that's it. Very, very functional, right? But it is finished, it's polished, right? There's a lot of functionality behind that particular page, right? So it doesn't have to be extremely complex. I see that a lot of you are adding carousels. That's great. If you're adding images or links to content that other users have provided. This is presumably a page that somebody comes and is not logged in. We don't know who they are, right? They haven't logged in. They haven't registered, and it's an invitation for them to join your particular community. Okay, either by showing that there's activity in your community, right? Check out these links to these articles that somebody wrote, or these reviews, or these movies, or these recipes that somebody has added, or whatever, right? Whatever your domain is, there should be a lot of eye candy here, right? In this landing page. Okay, there should be a page, a profile page that once I log in, once I know who, right, I should be able to go to my profile page and see my personal information, right? My first name, last name, whatever, right? And also show any information that is related to me, right? Whether if I created a comment, or I marked something, or I don't know, anything that is related to a particular user should be accessible through the profile page, right? Maybe not necessarily through the profile page, but there should be a place where I can see that, if I've created a relationship between a user and anything else, either a user related to another user because I've sent them a message, or maybe I'm following that user, or any relationship between a user, then I should be able to see that information here If I've created a review or commented or bookmarked anything, it should be here either in a tab form.
After the user logged in, they went back to the homepage and had their information on the homepage. So the homepage kind of doubled as their profile /
as their profile. So the homepage would react to who you're logged in.
And then once you're logged in, you go back and then there's more information.
Okay. Yeah, it could live on the homepage. So the homepage would look different on whether you're logged in or not. Sure. Yes. Yeah, that would be okay. That would be okay. I should be able to get somehow to the information that is related to the currently logged in user. Okay. Yeah. So the homepage can be interpreted as you know, if I go to Facebook and I'm not logged in, right? Is there a corporate Facebook page? Well, I don't know. It just challenged me immediately for me to log in, right? There is no eye candy, you know, Facebook page, right? Well, there is, but you know, basically it's meant for me to participate within my logged in identity, right? It's not meant to be used as a, you know, anybody can come and use the page, this website, right? It's meant for only when you log in. And that comes to another requirement that I'll get to in a minute. Any of the features if you're not logged in, okay? Ideally, most of the application should be available to me without logging in, okay? If you have a peculiar implementation that that you can convince me that you would have to be forced, and then we can argue and discuss that. Yes.
So our product is like social network.
Yes. Yeah, most social networking implementations will, you know, might not make sense unless you log in, right? And yeah, I could accept that, right? Although, you know, if you go to some pages that websites that also provide content like articles and things like that that is consumed by someone who's not logged in, right? You can make the counter argument, right? You can always provide some content for those that are not logged in, right? Perhaps not Facebook, since Facebook, you know, it's very one-to-one person, right? One to a group, but you know, more and more Facebook is a sort of content that is not user-specific, right? So that would be legitimate content that could be consumed by a non-logged in user. Yes, right? Providing all sorts of information about the economy, about, you know, things happening abroad. That's all legitimate. You can make the argument that says, well, no, I'm not going to let you see any user profile information unless you log in. That's also a good argument. Also, there should be some facility that would allow me to, some functionality that would allow me to search whatever it is that you want me to search, right? Whatever domain you've chosen, whether it's recipes, football teams, you know, whether it's travel, you should, you know, restaurants. You should allow me to search something, okay, and provide some search results that give me a summarized view of that search result, whether it's in a tabular format, whether it's a grid format or list or whatever way you want to display it, a summarized version of that. And once I click on one of these, I should be able to go to a details page, right? That shows me more information about whatever it is that you found, right? In your search results. This would be an extended view, right? Showing perhaps more information about that domain object, right? Whether it's a movie, maybe it'll show me who the director is and the filming location, such as any information that is related to that content, right? If it's a movie or book, there might be reviews about that book, right? Reviews created by users in your community, right? Those should be there, right? Listed in those details. Finally, there should be some kind of login or registration page that would provide me with user management. Okay. Styling requirements. So your website should be responsive, right? If you've been using Bootstrap all along, you should not worry, right? If you've been using Bootstrap, the templates, right? The HTML templates from Bootstrap, your website should already be responsive, right? Because Bootstrap has a file first philosophy, right? So that the first thing I'm going to do, I'm going to grab your application and see how it behaves as I stretch it, and shrink it. Right? I'm going to visit it with my iPad. I'll visit it with my iPhone and see what it looks like on the phone. Right? There shouldn't be any horizontal scrolling. Right? I shouldn't need to scroll left and right on the phone, unless. Right, there are some cases, for instance, where you have a tabular data, right? If it's a table that you're displaying, right? There's no way you're going to fit it on a phone, right? So Bootstrap provides responsive tables, right? And those tables are scrollable left and right. That's a legitimate use of a scroll bar, right? Left, right, scroll bar. Right? You have embedded tabular data. That's okay. That's okay, right? But for the encompassing the container of all your content, that should not have horizontal scroll bars. Let's see. Bootstrap, right? If you've been using Bootstrap, you should not be worried, right? You should be using the Bootstrap HTML templates. Feel free to override the look and feel from Bootstrap. There's plenty of free templates out there. If you go to Boot Swatch, right? There's quite a few really nice templates that override the Bootstrap look and feel. Here's a couple: Flatty, Journal, Darkly, Readable. There's one that looks like Ubuntu. Standard Bootstrap look and feel. These are some of the nav bars and buttons that are available. And the only thing you need to do is, this is a single file you need to change. A single file, right? The bootstrap.css, you replace it with the Bootstrap CSS for this particular theme. And immediately your look and feel changes. Okay? And then obviously you can do your own overrides, right? You can do your own overrides. But there are lots of free templates, plus some for pay. You can buy some of these, like $10. There's some really nice look and feels that for dashboards, right? That have some very nice interfaces. Okay, these are also very nice. Anyway. Take a look at, all right, close, shut up. Take a look at Boot Swatch, or there's quite a few others. What else? Yeah, so feel free to override the styling. White spacing. I've seen a lot of you, some of your current content that you're not using white spaces, right? So your content is flush with the sides, right? You're not putting any padding, you're not putting any margin. Right, so you make your content, nicely spaced from each other. Okay, so add padding, margins between content. Right, don't make things, content all scrunched up. Right, so add enough white space that it's not busy. Okay, make the content not look so busy. I've seen a lot of your content that I've seen is very busy. There's too much content in a page. Right? So space it out. Use white spacing. Okay, so use padding, use margins, right, in between content. Use justification, right? Certain things should be justified left, right, center, right? If it's a number, typically it should be justified to the right-hand side, right? Not everything should be centered like this. It might look weird, right? If it's lots of it, it typically looks nicer if it's all justified to the left. Right? So spend some time looking at this. Does this look pleasing? Right? So spend some time wrapping. Make sure that, especially when you start decreasing the size of your window, look at stuff that starts to wrap. Right? Do you want it to wrap? Maybe you do. Right? Maybe you don't want it to wrap. Right? So make sure that if it wraps, it's because you intended to wrap, and not because just the screen is smaller. Right? You can always feel should look professional, right? It should look polished, like you spent time looking at this, that this looks pretty, right? It's pleasing, that you'd be proud to show this off at one of your, right, when you're looking for a job, right? That here's a URL of something I worked on, right? You should, I am totally employable. Look at this, it looks amazing. Somebody looks at this, oh, come work with us. Right, so make it look very, very nice that you can include it in your resume and somebody can go and look at it and say, wow, this guy knows what he's doing, right? MVC requirements, some of this stuff is some of the basic stuff, but I want to formalize it. Your content, your JavaScript should be inside of immediately invoked functions, expressions, which we've been doing, right? Right, make sure that you're not littering the namespace, the dynamic content loading. So this is basically making sure that we are building a single page application, right? That the content is being loaded dynamically. If we've been using Angular UI routing, right, NG routing, you already know how to do this. We've been doing this for a while, right? Just want to formalize it here, right? Everything's broken up into templates and it's being loaded. Controllers. Right, you're going to use controllers on the front end to handle incoming user interaction. Avoid the use of scope, or if you have to use scope, use it very sparingly. Right, maybe at a top-level controller, right, or navigation controller. That might make sense. Yes.
I tried using scope, and then the results do not display on the first click of a button.
Okay.
And I need to use $apply.
Okay.
I don't know why is that happening.
Yeah, there might be a race condition. It might be that Angular is loading before before you have access to the data. So
I mean, when I do a web service call by clicking the search button,
yeah.
The results only appear when I click it. The results appear on the console right away.
Right.
But they do not appear on the UI.
Yeah. There might be a race condition on what in the order in which you're doing in which you're doing things. Are you using promises? Okay. Or are you using any callbacks, anything like that? We'll need to look at it specifically. Let's look at it right after class. Okay. Root scope. Root scope is as global as you can get in Angular, right? Again, use it sparingly, right? It allows you to store and functions, for access across all controllers, across any pages. Certainly use it to store global data, perhaps, but don't go crazy on it. Don't just put stuff in the root scope. For instance, the currently logged in user, maybe that makes sense to put that into the root scope. Avoid putting functions in the root scope. Okay, data, okay, sparingly, but functions, avoid doing that. You might use filters for that or something like that. What's wrong with this? Client, right? We've been doing this. Use factories to implement your web services. Any data access should go through a web service, right? You should never go directly from a controller to a web service, right? You should go through a shared web service client. The file structure, organize it like we've been looking at in class, right? The flat style and the deep deep style, right? Deep folder structure, and anything in between, right? So whatever makes sense for you, right? If you have lots and lots of views, then it makes sense to have a views folder, right? If you only have a couple of them, maybe it makes no sense to have a views folder, right? And you know, and this file structure is basically used for handling, you know, complexity, right? When you have a lot of files, right, you want to organize it so that you know where things are, right? You don't want to be hunting around. But once you choose a file structure, stick to it, right? And so it makes it easy for you or the team to find things. Search requirements, right? So this just says that you know, whatever domain you choose, there has to be a search functionality and a details functionality. User management. Your web application should allow people to register, to log in, to log out. You know, have a profile where they can see things are personal to them. Right. So they log into the login. See me if not. Okay, if you know, if it's not, ask me for permission first. Okay, and we can negotiate, right? Yeah, only require login when absolutely necessary. If you say it's always absolutely necessary, then we can agree on that. Like I give examples, right? If you know, a person is navigating through your website, if they want to review content or if they want to follow someone, well, I need to know who they are, right? Anytime I need to store something in the database, I need to know who you are. Profile requirements, right? Display all personal information regarding a user. If a user is logged in, then they can see the profile and edit it. Display all information about a user. Right, we talked about that already. Web service. So this is on the server. On the server side, there has to be RESTful web service implemented using Express. The URLs, if you'll notice, all our URLs follow a hierarchical structure, right? Well, most of them anyway, right? That capture the one-to-many relationship between the entities. One-to-many, user has many forms have many fields, right? All these URLs follow that pattern, right? So this is saying that you should as well, right? If you have a one-to-many relationship, you should follow that pattern. Use the various methods, right? The put, the post, the deletes, right? Make sure that if you're creating something, you're using post. If you're updating something, you're using put. If you're deleting something, you're using delete, right? If you're retrieving, it's a get, right? And only the web service should be interacting with the data model, right? You know, so we've been doing this for the last couple of weeks, right? Any access to the data should be through a web service. You know, if you have many web services implemented in separate files, and use promises, right, where necessary. Database requirements. All right, so, okay, some of you have asked me, you know, is a database required, right? And is a web API required? For me, I would do both, right? But there are specific cases that I've seen where maybe you're using a web API that already allows you to create content, right? Some of you are using Google Plus as the API. Some of you are using the Facebook API, right? And those already allow you to create content, right? Allow you to store data, right, on a separate server, right? And they have API that allows you to, you know, post new data, retrieve data, right? Change data, read data, right? So it's allowing you most of everything you could possibly do with your own database. Yes? Okay. So if you're using a web API and you're using fully, right, where you're creating and reading and updating and doing all this, then the database, I guess it's optional. I can see where the database would be optional. Right? There's nothing that I can enhance. I mean, just if instead you're using a web API for read-only, right, then you have to have a local database. Right? If you're just reading a list of restaurants around you, okay? So you're only reading this. If I'm going to bookmark it, where am I going to store that? Where am I going to store that I like this restaurant, or I don't like this restaurant, or I want to review it, or I want to comment. Where are you going to store it? Only in a local database, right? Right. So if your web API you're using only read-only, then you need to implement a local database. So that's why I said here and or. And if you're using web API, it depends what you're using it for. Okay. So data schema. So for you're gonna need to. So these are the requirements of the schema. You're gonna need to be able to model whatever domain object you are modeling, right? If it's a movie, if it's a car, if it's a recipe, if it's a restaurant, you'll need to model it. Yes. So you need to create a model for that. You'll need to create a one-to-many relationship, right? Now, whether the one-to-many relationship is embedded in an array or right? Either an embedded schema, a separate collection with a foreign key back to the parent, or the parent having an array of foreign keys back to the children. Yes? Right? In a relational database, we only have one of these possibilities, right? The children have foreign keys to the parent. Hence, which one you choose depends on what your particular life cycle for the objects is. Okay. Also, user-to-user relationship, whether a user is following another user, or a user is sending a message to another user, or somehow there's a relationship, developer and you are a consumer of my application, and we have some relationship. You'll need to choose whether you're using an embedded schema or not. The data model, you'll need to create an API, right? An API for handling the data model, right? So implement all the CRUD operations. Here's some of them. You might need to create more, right? Create, read. So all the CRUD operations, right? There's 3 versions for the read. You can read one, read all, or read giving a particular predicate. Doing for the last couple of weeks. External web API. So here's where I ask you, right? Depends what you're using the web API for. If it's read-only, you'll also need to create the local database. If you're using an API that allows you to create content, right, and then it's okay to just use the web API and not a local database. Right? That'd be unfortunate because that'd be a great opportunity for you to play with MongoDB. Here's some external web APIs where Google Maps or IMDb or YouTube, Yelp, Yahoo, Weather Channel, Yumly. I mean, there's tons of them. All right. What else? Any questions? Okay. Again, I've tried to make them as broad as possible. Many of you have many different ideas. Okay. Let's go on to the next topic. All right. So up to this point, we've basically covered the mean stack. Right. We could stop now and say we've covered mean stack. Right. We looked at MongoDB, the M in the mean stack. Right. And we looked at Mongoose on how to talk to a database. Is an API to talking to the database. We looked at E in the mean stack, which is Express, right, for creating web services and mapping incoming URL requests to backend processes. We looked at the A in mean, right? We looked at Angular as the front end MVC framework that interacts with the user, right? That receives incoming clicks and clicks and clacks from the user, and then through controllers, through services, and then fetching data from the server and re-updating the UI. We looked at the A, and the N, right? Node.js. That's in the mean stack, right? So the server where we're hosting all this, right? We're hosting the static content that is all our JavaScript, all our CSS, all our HTML. the Angular part, right? And also with Node.js is also hosting the web API portion of this, right? The Express that is receiving all these incoming requests. Okay. So what's left to do is two topics. The first of which we're going to cover this week and the beginning of next week is Passport. Right? We want to be able to secure our application. We want to make sure that there are two things really. In security, there's two main topics in security. One of them is knowing who you are, right? Who are you, right? And once I know who you are, then I like to apply some authorization, right, to your identity. Right? Now that I know who you are, what can you do once I know who you are? Right, so there's two things, two topics. One is authentication, and the other one is authorization. Yes, right. So we'll look at how to do that. Passport is mostly in the authentication portion of this, right? Solves the authentication piece of this, right? Of identifying, well, who are you? And there's many ways of identifying you. We'll look at a couple of these. Right, so we'll look at Passport, how to do that. The second issue in security is, right, once I know who you are, well, what can you see? What can you see? Or what can you do once I know who you are, right? Well, if I don't know who you are, if you haven't identified, I'll probably just show you a subset of my API, yes? I'm sorry, a subset of my web application. You certainly can't go to anybody's profile. You certainly can't do any administration. Right? So there's a whole set of pages, an entire pages that are not available to you because I don't know who you are, right? But not only should I protect the HTML content, the pages. Not only should I stop you from navigating to certain portions of the application, there's a whole other set of things that I need to protect, right? Because remember, right, our applications are single-page applications, right? They're JavaScript applications. These are resources that are being downloaded from the server. Yes, the HTML gets downloaded to a user's machine, right? To a foreign machine, to somebody else's machine, right? The JavaScript is downloaded to a foreign machine that we have no control over that machine, right? We can control our server because we built it, you know? We built the server and whatnot. But once it gets downloaded to somebody else's machine, we can't control that machine, right? That machine can look at the source code, right? Can look at the JavaScript. Even if we obfuscate the content, they can still look at that content, right? And there are tools that will reverse engineer that's the source code. Also, when users start clicking around in the application, they can always look at the network traffic that goes between, right, and the server. They can look at the traffic. They say, oh, look, you're posting and you're getting and you're deleting and you're putting. They see the URLs, right? There's nothing from them to stop them from taking those URLs, right, and try to, there's lots of these. Paste this URL, right, and start sending network connections to us, right? Even though, they're not using any UI, without needing any user interface, right? And looking at the URLs, they can kind of guess at what the relationship between our various entities are, right? And they say, oh, what if I send a delete? What if I send a put, and I try to modify things, right? And I start sending data across. I can post with JSON, right? So a malicious, a non-malicious entity, right? A user who's not malicious, they're not even going to try and do any of this, right? We have to worry about those that are malicious, right? They're looking at our network and start trying to poke at our services, web services. Yes. So it's not only do we need to protect swaths of HTML content that we don't want you to get to, we also have to protect that network connection. You see that? We need to protect from these posts, these deletes, these puts that someone might use, right? So we have to for pages, for URLs, for content, we need to protect that, but we also have to have an identity of these incoming URLs that ask for data, not content. They're asking for data, right? That are meaning to modify our data in the server. Yeah. I have access to a user, and I see that there's a role, right? And somehow I can post and set myself as an admin, right? It says, ooh, I'm an admin now. I can log in, and I already existed, right? I already exist. Maybe I log in as a normal user, as a regular user, and in the network I see that it's going back and forth, right? Role, ooh, role, right? It says, ooh, can I post? Can I put and change myself as a different user? Anyway, so we have to protect both that we create. So we're going to be using Passport. Passport.js. So Passport.js is a Node.js tool that tries to standardize, right, authentication and authorization for Node.js applications, right? It tries to create a layer, right, that is standard across a multitude ways of authenticating. Okay, there are, you can authenticate using username and password, right? You can authenticate providing some kind of an encrypted key or cookie, right? You can authenticate through OAuth, right? It's very popular. Maybe you can authenticate by sending you over to a well-trusted entity, right? Such as either Google or LinkedIn or Facebook, right? And then if they authenticate and say who and they agree that you are who they say they are, right? Then they can come back to our application as an authenticated user. Use that identity from somebody else's authentication, right? So Passport looks to create a custom API across all the various ways that you can authenticate, right? Hiding, right, secrecies of each one of these ways of authenticating. Right? And what Passport calls all these various ways of authenticating, Passport calls them strategies. Okay? Various strategies that you can authenticate, right? If you go and look at some of these strategies, these are some of the strategies that Passport supports, right? So, right, allows you to authenticate through Twitter or Google, right? Or LinkedIn or Auth, right? Or Steam, right? If you're a gamer, or Instagram or Dropbox, right? So it already has done the grunt work of the identity providers, right? So that and created a standard API above it. Okay, so you don't have to learn, right, each single way of authenticating, right? You can always put Passport on top of that, right? We're going to start off with the simplest of these strategies, right? The simplest of these strategies is just plain old username and password. Okay, that's the simplest. So I'm not going to go out to anybody, right? I'm just going to provide you with a possibility of you providing with username and password. I'm just going to make a local lookup in the database if this user exists with this username. In the next lecture, we're going to look at using one of these strategies, right? So for instance, going back to Google and Google allowing us to authenticate and then providing an identity, right? Which we can then use to perhaps, right, go back and talk to a Google API, right, for retrieving, personal data from Google. Google Plus, right? A list of users, my email, my whatever, right? Whatever information I already have stored in the Google identity, right? So we'll start by using the simplest of these, right? Which is Passport Local is called. local. Anyway, to install Passport, it's a Node.js module. You just say npm install Passport. Right, that will install the Passport module. You also need to install whatever strategy you're using. Right? So if you're using the local strategy, you'll need to also do npm install local, passport-local. Or if you're using Facebook, you'll need to install npm install passport-facebook-twitter-google- whatever. Okay, each strategy that you want to use. Right, we're going to be using the simplest of these strategies, which is local. So let's take a look at a simple. This is a separate project. This is a separate project which I have on GitHub. Right, I'm gonna send you a link to all of you so you could take a look at it. Right, but let's look at how it works. Okay. All right. So most of this should be familiar to you, right? This is the server.js. This is plain old server.js, right? That you would run just saying node space server.js, right? And the first thing that it does is a couple things that you already should be familiar with. Let's see. Instantiates Express, right? That's the Express module, which we've been using for the last month or so. It creates an instance of Express. Here's body parser. Multer, we don't need Multer, but it's very common. It's a very common package to load for dealing with forms, right, and multi-part forms. Right? Although we're not using it, it's a very common thing to load as well. And here's where we load Passport. There it is, right? We're requiring Passport, and we're loading also the strategy that we're using, which is the local strategy, right? If you'd be using the Facebook strategy, you would load the Passport-Facebook strategy, right? Or the Passport-Google strategy, or whatever strategy you want to use. Right? Here we're using the local strategy. Now, Passport is going to use, right? It's going to use what it's going to do. What it's going to do, right? It's going to encrypt a cookie. It's going to create an encrypted cookie that's going to use to go back and forth between the client, right, and the server. Right? It's going to use this encrypted cookie to identify whether it's you, right? And it's going to add session information to that cookie, so that the server can then identify that the same cookie that it generated, it says, yeah, this is a cookie I created. Right? I'm gonna decrypt it. It says, yes, I created this cookie. I know you are safe to talk to. It doesn't matter if someone is in between, right, and captures this cookie. It'll be useless to them, right? They're not going to be able to modify it. If they try to modify it, right, the cookie won't, whoever receives the cookie, the Passport is going to decrypt and see that's not the cookie I created. So because a Passport needs to be able to generate, parse, modify cookies, there is a cookie parser module that we'll need as well. Okay, so cookie parser, again, that's also a module, Node.js module. We also going to use another Node.js module called the session module. Right, the session module allows you to maintain state. Right, allows you to save data in a session, right, in the local session. Allows you to take a cookie, right, and a cookie, some information, right? It says this cookie is associated to this state. If it's someone else coming in with a different cookie, they'll have a different state, right? It allows to have a stateful conversation, right? I don't know if you've heard this protocol. Yes, right. This was a problem early on when HTTP just came out, right? When it just came out early in the 90s, where there was a huge explosion of people creating websites, right? And says, oh, it's stateless. So the server didn't know how to distinguish between, any any incoming requests from any browser, right? So all the pages look the same, regardless of who visited, right? So to fix this, they invented this notion of the cookie, right? What if I create a cookie in such a way that the server can then have some logic and distinguish the incoming request? And it says, oh, you're this guy and you're this other guy. So I can respond differently to different users. I can distinguish you, right? And so the information, right, now the store data for each individual user, right? Typically sessions, typically we try to make applications as stateless as possible, right? Which, that's what we've been doing, right? We've been creating very stateless applications, right? The server sees an incoming, fulfills that request and sends it back. And then forgets it, doesn't have to remember anything about that incoming request, right? Everything goes right to the database, retrieves the data, and then sends it. The server never remembers anything, right? I don't know if you've noticed, right? All our web services, right, don't remember anything about any user, right? But it is able to store data. It's able to store data because all the incoming requests go to the database. Here, we are going to be using session, right? We're going to store session information in that cookie, and we're going to use it to retrieve data that we store in that session. The only thing we're going to store in that session is password, things like that, right? That we're going to be able to use to identify that person. Okay. We're using Mongoose, right? We're creating a database connection to Mongoose, so that's not new. Okay. Body parser, that's not new. We've done that before. So there's a couple things that are new here. One of the things is session, right? We're configuring the session to be encrypted. So it's the session information that's going to be going back and forth, the data that is going to go back and forth, we want it to be encrypted. You need a key, right? You need a key to be able to decipher. This is the cipher, right? This is the equivalent of a cipher. It's a key that typically you maintain private, right? Nobody knows your secret. Nobody knows your key, and that's fine because it's a server-side code, right? Nobody should be able to see this. Only the developer should be able to see this, right? This is not information that goes back to the client, right? It's not made public to anyone, right? And it could be anything, right? It could be anything at all, but it needs to be kept secret. It cannot make its way. Once this secret is made public, then the communication is compromised, right? They could decipher the communication between the client and the server by knowing this, right? So this needs whatever you choose here needs to be made secret. Here's the initialization of cookie parser. Here's the initialization of the passport, right? And initialization of the passport session. This has to be done in this order. First, you need to initialize Node.js's session, and then you need to initialize passport session because passport uses Node.js's session. Okay, so first you initialize Node.js's session, and then you initialize passport sessions, which is going to use Node.js session. Here's the status. HTML, CSS, right, in the public directory. And here's the schema, right? Right now we're going to handle a couple things, just a user. So it's a very, very simple user schema. It's just, just to get you going on what can be done. Obviously, you're more than welcome to reuse any of this. But right now we have users having a schema that's going to be stored in the database of username, password, first name, last name, email, and roles. Right? A user can be in many roles, right? And I'm going to store it in a collection in MongoDB called, the name of the project is called me plus the collection I'm going to use. What else? We create a model. create a model. And then we start configuring Passport. We start configuring Passport. One of the things we're going to configure, one of the things that we're going to configure is serialization and deserialization, right? What happens is that we need to be able to, right, as users log in, right, and they're communicating with us, right, there's session information that goes back and forth that is encoded in the cookie, right? We need to decipher the content of that cookie, right, and then map it, right, and reinstantiate the user, right, from that unencrypted data, right? And these two functions, serialized user and deserialized user, is what does this, right? The serialization means that I'm going to take the user information, I'm going to encipher it, right, and then put it in the cookie, right? Deserializing is backwards, right? I'm going to have the cookie information, right? I'm going to get the user identity. I'm going to make sure that user is in the database, right? Serialization, right, is their API, the Passport API, is going to give us the serialized user, and we're just going, and it provides us this kind of, it's a promise object that gets passed to us that, this would allow us to inject code in here when we're serializing the user. We're not going to do anything. It's already serialized for us. We're just going to return the user as being already serialized. We're not going to do any modifications to the user. One of the things that we might do here is, for instance, remove a password, for instance. We never want to have the actual password go out, right, outside of the serialized. We're not doing anything here. We're letting it go. We're assuming that it's already going to be encrypted, right? It's okay for the password to be already enciphered in there. For deserialized user, we are going to, it's going to decipher the user coming from the cookie. And it's going to provide us with the data that comes from the cookie. It says, here it is. Here's the data that has been decrypted from the cookie. What do you want to do with it? Well, we're going to go to the database. We're going to go out to the database and say the object that's going to be the ID, the unique ID that identifies the user. I'm going to look it up in the database and make sure that this user still exists, right? And I go out and I find the user by the ID, and once the user comes in, the done is, again, it's like a promise. It's waiting for it to come back. And here's where we could either send an error or use it. We're just passing it along, right, to the endpoints. So what happens here is that these two, right? What happened is that in all communications, right? Whenever you have a post or a get or put or delete, right? Typically, what do? We just have a regular get, right? We have a regular get, a URL, and then the function, right? That's how we create our web service, right? Here's a post, here's a URL, and then the function. Here's a post, the URL, and the function. That's what we've been doing for the last couple of weeks, haven't we? Right? We're going to add one more thing. We're going to say, hey, I don't just want you to just come in here, right? I want you to here's a function out here. You see that? But in between, look at what we've done. We've added passport.authenticate local. See that? We're saying before you post through, right, before you let this through, authenticate the incoming cookie, see if they are who they are, right? Okay, and we're saying what strategy do we want to use, right? We're using the local strategy. So what this is doing, right, is that it's injecting itself in between the incoming HTTP request and the function here, right? If the URL comes in, Passport is going to intercept that incoming HTTP request, right, before put, here comes the delete, right? And we were executing all sorts of functions, right? To the functions to delete, right? The find, find by, whatever, right? By adding this, this middleware, right? This middleware in between, we're saying, hey, I want you to intercept the incoming HTTP, do the serialization, right? The deserialization is when it's coming in. Do the serialization. Also, here's a configuration on what I want that incoming request to do, right? I'm going to use, I'm telling it I want to use the local strategy, right? What this is going to do is that it's going to assume that there's going to be a username and password in the form, right? In the as attributes, as properties of the incoming object, right? It's going to parse out that username and password, right? It's going to parse it out, and it's going to provide it to us in this function, right? And the way we make sure that this user actually exists is that we actually do a find, right? We're going to use the username and password one whose username matches the incoming username, and the incoming password also matches that password. If we find it, right? If the user this is a two error, right? We're just going to done is a part of the API, part of the passport API, right? It's a function that gets passed to us like a callback, right? Where we can tell passport, we can notify passport, right, of anything that happened, whether it was successful or not. We can notify passport saying, hey, there's an error, or if there is no error, right, we can provide a null for the error. There was no error, but we can say that this user doesn't exist, right? There is no user with that username and password, and kind of abort saying that this user doesn't exist, right? It's not a valid user. Or if the user does exist, right, and there was no error, right, we can tell passport there was no error, and this is the user. This is a valid user, and here it is. This is the user object that I found in the database. Okay, so that is what all this does, right? It uses those two functions. One of them is deserializes it, deserializes the incoming cookie, and then once it has deserialized the cookie, it's going to use the username and password, find out if that user actually exists, right? And notify the passport framework whether it was successful or not. Okay? If it wasn't successful, this function will not be called. This function will not even exist, will not execute. Right, back to the client saying unauthorized access, right? And the client is going to have to, show some error message saying, no user found or whatever. Okay. If the user does exist, then this happens. Okay. The only thing that we're doing here, we're not doing much. We're just echoing, right? Perhaps this is not a good idea. Well, we're echoing back the user, right? We're just saying this is the current user, right? And it's logged in. There are a couple more. We have here's one that we can check whether a user is logged in. For instance, as we go from one page to the next, right? As we change state from one page to the next, we might want to check whether this user is still logged in. Maybe they timed out, right? Maybe they haven't since the last time. We want to verify this user is still logged in. We can call. We can go back to the database, to the server, and say, hey, is this user logged in? Okay. In the request, all this notification, all this communication backwards and forwards, all the communication, it's always going to go through this serialize and deserialize. Okay. It's always going to go through that. So in the request object, right, passport adds a couple of right that allow us to query passport. Say, hey, is this user still logged in? Does this user still exist? So the request object is enhanced by passport, so that it has, for instance, this is authenticated method is a passport function that was right, and we can ask it, hey, is the current request authenticated? Meaning, is this incoming cookie, right? There's, is it valid? Does it match to a known user, right? So there's a question mark. Is the user authenticated? If it's true, then we are going to send back the user. Otherwise, we're going to send back a 0, right? And the client can use this 0 as meaning that the user is no longer logged in. Okay. Log out. Right. Somebody can post. Click on a log out button. Right, and it'll post here a log out. Again, passport has enhanced the request object, has enhanced it with a logout function. What this does is that it invalidates the cookie. It says this cookie is no longer valid. It cleans the session, right? It throws away the cookie and says, I no longer recognize incoming requests from this client. And then it sends register is not protected, right? So in the request, there's not going to be a cookie. Well, or maybe there is, right? But we don't care, because presumably this is going to be a new user. We're not expecting any session information, right? Even if there is, not even going to look at it. What we're going to do is we're going to presumably they have filled out a form. They've provided user information, right? We're going to extract that from the incoming JSON, right, submitted by a registration page, right? And we're going to give the user a default role. Registers as a default role of student. Okay. Remember, in the schema, right, roles is just an array of strings, right? So you could have many roles here, right? We could use these as foreign keys. Right, this could be a foreign key that can be used by another collection of roles, right? And then in the roles in that other collection, we can have all sorts of configuration of what each role means and what each role can do. Right? But here, we're just going to keep track of the roles by name, right? Additional code, right, could look at these roles and and let you do certain things or stop you from doing certain things, right? Anyway, in the registration, we take the new user, we try to find to see if that user already exists, right? We look, right, whether there is a username with the username of the new user. Does this user already exist? If there's an error, right? So next is a function of express, right? Express also uses promises, right, and processes waiting on each other. Next just says, wherever you were going, right, whoever the next process is, just send them the error. Okay, this one checks to see if there's a user. If the user exists, meaning it's not null or empty or nothing, it's going to send back a null. Right, this is going to be a flag for the client to say, hey, this user already exists, right? Something went wrong, and I'm going to return. If there is no user, right, it's going to continue here. It's going to create a new instance of the user, right? And it's going to go to a database and save that new user. It's going to make an insert of that new user, and it's going to use passport. There's another function added by passport called login. Okay, what logging is going to do is going to take the user representation, right? And it's going to add the session information, encrypted, right? And so that, and send it back to the client, right? So that the client, whenever they come back, they're going to have a valid cookie, right? So it says all this is going to be stored in the session, saying, this user has been encrypted, right? I'm going to remember this user with this session cookie, and whenever they come in with a cookie, I'm going to get back that particular user with that particular cookie. If there's an error, I return the error. Otherwise, right, I'm just going to echo back the user back to the client. Down below, we have a couple of depending on whether we are admins or not. So for instance, get a user, right? Get a user. Notice that what we're doing here is that we're putting in between, right? We're not going to let this function go through unless guy is satisfied, right? So auth is a function up here, right, that basically takes the incoming request and response, right, and asks, is the user authenticated? If it is, if it's not authenticated, it's gonna just so this is kind of like a filter, right? If you've done Java development, this is the equivalent of a filter, okay? Right, so this is what it's doing, is it's looking at the incoming HTTP request. It's first executing this. If it's successful, like next, right? If it's successful, then it'll execute the next function. Otherwise, it's over here, right? It's just going to respond a 4.1, which means unauthorized, right? So if you're looking for all the users, well, you better be authenticated. You better be authenticated. If you're not authenticated, if you are authenticated, yes, we're going to retrieve all the users, right? A find, notice that is a dot find, retrieves all the users. Then we're going to respond with all users. These are all protected. These are all protected. Look at delete also. I'm going to first authenticate you, right? And I'm not going to do any of this unless you are authenticated, right? If you are authenticated, I'm going to retrieve that user and I'm going to remove it, and then I'm going to respond with all the rest of the users. If I want to modify a user, again, I'm going to check to see if you're authenticated. And if you are authenticated, I'm going to look you up by ID, and I'm going to change you. Let's see, what's this? Oh, this is roles. I'm looking at the roles. I'm checking to see if the roles is a comma separated string, right? If it's a comma separated string, then that means that you want to be able to be in all those role, in a faculty role, in an admin role. You can be many roles, right? And they're comma separated. And then if they're comma separated, right? If I find a comma in the string, I'm going to create an array of those strings, right? And then I'm going to set the roles of strings as opposed to a string with commas. And then I find the object. I update that particular user, and then I retrieve all the users. Posts, right? If I want to create a new user, to get it, I'm going to see if that user already exists. If the user does not exist, then yes, I am going to create a new user in the database. Otherwise, I'm just going to find that user. I'm going to return the user, the existing user. I'm not going to create another user that has exactly the same username and password. And finally, the server. So this is the server. We got to look at the client. Before we look at the client, let me run it for you. Let's see. Okay, the server's not running. Let me start to run the server. Let me run it for you just to get you an idea of what this looks like. Node server. It looks like it's running. Okay, there it is. So it's a very, I've tried to make it as simple as possible, so it'll be a starting point for you, right? That you can then pick and choose the things you want, right? But it has more or less all the features, right? Being able to, here's a default home page for those that are not logged in, right? And you have the 3 links that will be available to you when you're not logged in. You have home, you have be able to log in, right? Or register. Log in if you already have an account, or register if you don't, right? And it's using the table. I'm using the table mean plus passport dot user. So let's look at that. Let's go to Mongo and show DBs. So we are using this one, right? Which one is it? Yep. And that's the collection. What's the database we're using? We're using mean plus passport. We're using that database. So let's go into that database. So use mean plus passport. Okay. And show collections. So we have user. Okay. So this was from a previous example I ran. So yeah. So if we're using this collection, we'll use this collection, which doesn't exist. Passport.user. So if I try log in, nothing will work. I don't have any users. But I just want to show you in the network, right? When I do a login, notice that it comes back as red. See that? It comes back with a 4. Okay, 4.1 means unauthorized access. Right? You have an unauthorized access. Right, unauthorized. 4.1. So I don't have any users. So let's register. Let's go to register. And I'm going to register as Alice, passport Alice, passport Alice. So we register, and notice that it navigates to the profile, right? Because presumably you've registered, you've given me a password, you're logged in. So you're in a logged in state. Notice that at the top, right, the URL's changed a little bit. But we still have access to home. We have access to, now we have access to our profile link, which we didn't have earlier, right? And I don't have access to login anymore. I don't have access to register anymore, but I do have access to log out, right? Also notice that we have access to some personal information, which I can change. I can say this is Alice. I can update. Notice that it's updated. I notice that there's a put that. If I refresh, notice that I don't lose state information, right? The page refreshes, goes out to the database to fetch the data again, right? And lists the content. If I navigate to another page like home, right? Notice that it knows who I am, right? Notice that who I am. It says, welcome Alice. Right, so it has information about this. If I refresh the page, state is maintained. My state is maintained. Right. If I log out, now notice that my links change to login and register. I don't know who you are anymore. Right. So notice that I'm not saying hello anymore. I can't go to profile. It kicks me out to log in. Right. Any admin or anything that is protected will not let me through. If I use Alice and I log in, it does find me who I am, right? And it goes back to my profile and my logout. I don't have access to admin because I'm not in that role, right? I can go back to the database to the database and see the entry here, right? So we can have, you can list the collections again. Notice that we have now mean plus passport.user now, right? So we can look at the content in here, db mean plus passport.user dot find. Oh, I used a collection that it doesn't like. Let me use a dot notation instead of the plus. Try it again. Dot. Okay, let me restart the server. Right? And I don't have Alice anymore because it's a different collection. Right? It's a different collection. So let's register as Alice. I'm here, and let me go back to Mongo. And oops, not this one. So it's dot. Okay, there we go. And we can say pretty. Oh, there we go. So we have username Alice, password Alice, and the role admin, right? That is able to create other admins, for instance, right? Right now, the only way that we could do that is by modifying the database, right? Very, very secure. Only the admin has access to the database console, so they can update the user. We can say update a user. User updates a user whose username is Alice. I want to set the roles, right, to be not only student but also admin. I'm going to close that. I'm going to close that. I think that's it. Let's see. Okay, if I look at, there we go. So Alice is now a student and an admin, right? If I go back, right, and I refresh my page, right, notice that now I also have the admin link at the top, right? This is what I meant earlier by authorization, right? There's authentication. I want to know who is authentication. Now that I know who you are, what can you do? Now you do have access to the admin link, which wasn't there at first. And first it was kicking me out, right? Before I typed admin here and it wasn't letting me go, right? But now if I do that, I do have access to the admin link, right? So the link wasn't there and the page wasn't there, right? And that's protecting the page flow, right? But we also have to protect the puts and the posts and the deletes as well. Those have to be protected as well, because even though I don't have access to the page, I might start sending you puts and deletes. Bob. And if I say faculty, so they're in faculty. Ooh, they're not set password. I can edit them. Oh, or I can change the faculty and make them an admin as well. Or no, faculty, the dean. You notice that it changes here. But if I log out and I log in as Bob, the admin link, and even though I'm logged in, I still have no access to the admin, right? It says, no, you don't have access to the admin. And you can still go to your profile, but if you do want admin, you need to log in as someone else, okay? If I log out, if I log in as Alice, right, then I do have access to the admin. So this is what I meant by, notice that I'm not logged in, and one of the requirements is that if you try to do something, right, where you're not logged in, then you will be kicked out to the login page to identify yourself. But I still have access to my home page, right? I can see things, right? You can show me most of the content without forcing me to log in, right? Only when I need to know who you are, then I force you to log in. Make sense? All right, I'm going to make available this example. It's just a GitHub link. I'll post it on Piazza so you can clone it and start playing around with it. Obviously, much more when you start putting promises and services and controllers and models and schemas and whatnot. Again, I try to make it as bare bones as possible so that you can follow along, right? And then you can make it more sophisticated as we go along. All right. All right. Thank you. Oh, I gotta stop here.